Hey students, welcome back. This is going to be 7.5, but just in case you need the bell ringer, it's right here. So go ahead and hit pause and then meet me down below. All right, so 7.5, we are talking about the combined gas law, which is our notes are page 17, combined gas law. So what we're going to do here is we're going to start by reviewing Boyle's law and then Charles' law. So we remember the formula for Boyle's law is P1 V1 equals P2 V2. All right, our formula for Charles' law is V1 over T1 equals V2 over T2. Now, if you look, we have V's in similar there, right? Our V's, boop, we got V, 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 right? So we can actually squish this all together to get our formula, like if we just bring it all together. And we're going to jump to that formula part below, and then we'll come back to the PV, the standard temperature and pressure. So the formula for the combined gas law is P1 V1 over T1 equals P2 V2 over T2. Now it is my suggestion that you write it P1 V1 T2 equals P2 V2 T1. That way you do not have to worry about fractions. All right. So let's jump back up and talk about standard temperature and pressure. Standard temperature and pressure, aka STP, is a specialized place, and this is something that happens quite a bit. That's why it has its own little name. So what we have here is we have 1 atm of pressure, which is atmospheric pressure, right? This is what it normally is, atmospheric pressure, and 0 degrees Celsius. All right, so we have 1 atm and 0 degrees Celsius. So anytime you see STP, you know you have these two conditions. All right, so remember our temperatures always have to be in Kelvin. That has not changed because we do not want any negatives. So let's see if we can't go ahead and solve some problems here and go from there. So we have two examples today. We have 9 liters of air has a pressure of 117 kilopascal, a temperature of negative 25 degrees C, temperature is raised to 107, and the volume expands to 17 liters. We are looking for the new pressure in ATM. So we're looking for P2. Let's go back through and assign. So this is my first volume. I know that because there's a liter there. This is my first pressure because it's kPa. Then we have T1, all right, and this is T2. This is V2. So kind of writing along the side like I've been doing. I'm going to blow this up just a little bit since we have all our numbers there. So P1 is going to be equal to 117 kPa. V1 is equal to 9.00 liters. T2 is going to be equal to that 107 degrees C, but I need to add 273.15 to it to get me to Kelvin. All right. P2 is what we're looking for. V2 is that 17 liters. And T1, our initial temperature, negative 25 degrees C. All right. Oh, and we're going to add 273.15 to that. So hopefully you have your calculator handy. And let's go ahead and do our temperature calculations first. So we've got 107 plus 273.15. That answer is going to be 380.15. Then we've got negative 25 plus 273.15, and we get 248.15. Okay. So over here, our formula, P1 V1 T2 equals P2 V2 T1. All right, so at this point, there's a couple of things that we could do here. We could go from kilopascal to ATM right now if we wanted to, because this is supposed to be an ATM, or we could just wait till the very end. In this case, let's wait till the very end because why not, right? We really have lots of options. So we're going to put 117 in times V1, which is 9, times T2, which is 380.15, is equal to P2, that's what we're looking for, times V2, 17, times 248.15. All right, now we're ready to do our math. Remember, we're trying to isolate P2, so we're trying to get P2 by itself. So if we divide, let's change colors there. All right, we're going to divide by 17 and 248 on each side, because over here that will cancel, right? All right, so P2, blowing this up a little bit, P2 is going to be equal to 117 times 9 times 380.15. Then we're going to divide by 17 and 248.15. And that should be our answer. And this is going to be in kPa, so we're going to have to do a little work to get to ATM. So 117 times 9 times 380.15 divided by 17 divided by 248.15, and we should get 94.89, and that's kilopascals. So now we need to take this just a step further, and we need to go to ATM. So we know that 101.325 kPa equals 1 ATM. And so if we divide that number by 101.325, we get our atmospheric pressure, or our atmospheres, which is 0.94 ATM. And that's our answer for that first one. So we did a lot of things in that problem, kind of to quickly review, right? We used the combined gas law, P1V1 equals, or P1V1 T2 equals P2V2 T1, and then we converted from kilopascals to atmospheres for our answer. All right, so let's try one more example there. All right, this one we're looking for, kind of going through here. We've got T1, that's our first temperature, 41 degrees, or 47 degrees. That's our first pressure. There's our first volume. Okay, what volume? We're looking for V2 in this case. And we have T2, 107 again, and P2. So this time we're looking for volume. And let's just write what we know down the side there. P1 is equal to 1.03 ATM. Whoops. V1 is equal to 2.20 liters. T2, our T2, that 107, and we actually did that math up above, so we can go ahead and reuse that if we want, 380.15. P2 is 0.789, so our pressure is going down. They're both in atmospheres, so that's awesome. V2 is our question mark, and T1 is that 47 degrees C. So we're going to have to add 273.15 to that. Let's go ahead and do that. That is 320.15. All right, now we're ready to plug it in there. So remember our formula, P1 V1 T2 equals P2 V2 T1. And we should be ready to just kind of throw stuff in there. P1, 1.03 times V1, 2.20, T2, 380.15. P2 is at 0.789. V2 is what we're looking for. And T2 or T1, 320.15. All right, so now again, trying to get back, we're trying to isolate V2, so we're going to divide each side by 0.789 and 320.15. Divide each side by 0.789 and 320.15. Right? Boop, 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 boop. So V2 is going to be equal to 1.03 times 2.20 times 380.15 divided by 0.789, that is not a 7, 789 times 320.15. So let's go ahead and see our calculation here. 1.03 times 2.2 times 380.15 divided by 0.789 divided by 320.15, and our answer should be 3.41, and our label on that is liters because our other volume was in liters, so our answer is in liters. All right, see you next time.